Adapters. The world of computer hardware is often a battleground of conflicting standards. As technology evolves, new interfaces like USB-C and DisplayPort frequently leave behind perfectly functional legacy devices like VGA monitors or older serial peripherals. Adapters and converters are the essential tools that bridge this gap, allowing a technician to maintain compatibility across different generations of hardware. While the terms are often used interchangeably, there is a profound technical difference between a simple physical adapter and an active electronic converter. Understanding this distinction is vital for ensuring signal integrity and preventing hardware damage. The passive adapter, physical realignment. A passive adapter is the simplest form of connectivity bridge. It does not contain any complex electronics, integrated circuits, or brains. Instead, its only job is to physically reroute the wires from one connector shape to another. This is only possible when the two interfaces being connected already speak the same language, meaning they use the same electrical voltages and the same data protocols. A classic example of a passive adapter is the DVI to HDMI adapter. Because the video portion of DVI and HDMI both use the exact same TMDS, transition minimized differential signaling protocol, the adapter simply takes the pins from the DVI side and maps them to the corresponding pins on the HDMI side. No signal processing is required. Similarly, a USB-C to USB-A adapter is usually passive. It simply maps the 4 or 9 pins of the older USB standard to the correct pins within the 24-pin USB-C housing. The primary advantage of passive adapters is their low cost and high reliability. Since there are no active components to fail or overheat, they typically last as long as the physical metal pins remain intact. However, their major limitation is that they cannot bridge different signal types. You cannot use a passive adapter to connect a digital-only DVI-D port to an analog VGA monitor, as there is no way for a simple wire to translate digital ones and zeros into analog voltages. The active converter, signal translation. When the two interfaces you are trying to connect speak different languages, you must use an active converter. An active converter contains a small specialized computer chip known as a signal processor or an encoder that physically changes the data as it passes through. Consider the HDMI to VGA converter. This is one of the most common tools in a technician's bag. HDMI is a digital signal, while VGA is analog. An active converter must take the incoming digital stream, decode it, and then use a digital-to-analog converter, DAC, to create the varying electrical voltages required by the VGA monitor. Because this process requires mathematical calculations, active converters usually require a small amount of power. In many cases, they steal this power from the HDMI or DisplayPort itself, but in some high-performance scenarios, the converter might have its own dedicated USB power cable. Active converters are essential for modern, thin-and light laptops that only have digital outputs like USB-C or mini DisplayPort, but need to connect to older analog projectors in conference rooms. A key troubleshooting detail for technicians is that active converters are almost always unidirectional. An HDMI to VGA converter will only work in one direction. You cannot flip it around to connect an old VGA computer to a modern HDMI television. Video adapters, bridging the visual gap. The variety of video standards has led to a massive ecosystem of specialized adapters. Each has its own rules for what can and cannot be adapted. DisplayPort to HDMI. This is a unique case known as dual-mode DisplayPort, DP++. Most modern DisplayPort outputs can sense when an HDMI adapter is plugged in. The graphics card then automatically switches its output to speak the HDMI language. This allows for very inexpensive passive adapters. However, if the graphics card does not support DP++, you must use a more expensive, active adapter. USB-C to DisplayPort HDMI. These adapters utilize alt mode. The USB-C port physically reroutes its high-speed data lanes to send a native video signal. This is a very high-performance connection that supports 4K and even 8K resolutions, provided the cable and the port are both rated for the required bandwidth. DVI to VGA. As discussed in our DVI deep dive, a DVI port contains both digital and analog pins. A simple $5 passive adapter can be used to pull out the analog signals from the 4 extra pins around the flat blade and send them to a VGA monitor. Data and peripheral adapters. Beyond video, adapters are used to bridge various data and power standards. USB to serial, RS-232. Since modern laptops no longer include the 9-pin DB9 port, this is perhaps the most important adapter for a network technician. These are all S-active. They contain a specialized bridge chip, like those made by Prolific or FTDI, that creates a virtual COM port on the computer, allowing modern software to communicate with legacy routers and switches. SATA to USB. These are active converters used for data recovery. They contain a controller that makes a bare internal hard drive appear to the computer as a standard USB mass storage device. These often require an external power brick for 12-volt mechanical drives, while smaller 2.5-inch SSDs can often run on USB power alone. Molex to SATA power. These are simple passive adapters used to power modern SATA drives in older computers that only have the 4-pin white Molex connectors. Technicians must be cautious here. Low-quality Molex to SATA adapters are notorious for causing electrical shorts and fires if the plastic molding is poorly manufactured. Troubleshooting and signal integrity. Adapters are often the weakest link in a hardware chain. Every time you add an adapter, you introduce 2 more physical connection points where pins can be bent, dust can accumulate, or a cable can be bumped loose. 1. The handshaking failure. In digital systems like HDMI and DisplayPort, the monitor and the computer must perform a handshake to agree on a resolution and to verify HDCP, high bandwidth digital content protection. A low-quality or incompatible adapter can interfere with this handshake, resulting in a blank screen or a resolution not supported error. 2. Resolution limits. Many cheap adapters are limited to 1080p resolution. If a technician tries to use a basic HDMI to DVI adapter with a high-resolution 1440p monitor, the image will likely be distorted or fail to appear entirely. Always check the maximum supported resolution of the adapter itself before blaming the monitor or the graphics card. 3. Latency. Because active converters must process the signal, they can introduce a very small amount of input lag. While this is usually unnoticeable for office work, it can be a major issue for high-speed gaming or professional video synchronization. In these cases, a native cable connection is always superior to an adapted one. Conclusion: the technician's tool belt. Adapters and converters are the Swiss Army knives of the IT world. They allow a business to extend the life of expensive projectors and monitors, enable technicians to configure ancient hardware with modern laptops, and facilitate the recovery of critical data from legacy storage. By understanding whether a connection requires a simple passive physical rerouting or a complex active electronic translation, a technician can ensure a stable, high-performance link regardless of the age or the interface of the devices involved.